You know that sharp, pungent smell? The one you instantly recognize, whether it's from a cleaning product or, well, other public spaces. But what if I told you that smell belongs to one of the most important, world-changing chemicals on Earth? Let's go on a little journey and uncover the science behind it. All right, so think about this for a second. What could possibly connect household cleaners, the industrial fertilizers that literally feed the world, and yeah, that unmistakable eye-watering smell you sometimes get outside a public urinal? What's the link? Well, the answer is ammonia, NH3, a simple little molecule, just one nitrogen and three hydrogen atoms. That pungent smell is the signature of a chemical that is, and I'm not exaggerating, absolutely fundamental to our modern world. Okay, so to really get a handle on ammonia, we have to start with its most dramatic property. And honestly, it's basically a superpower. I'm talking about its relationship with water. So in chemistry, we call this solubility, right? It's just how much of one thing you can dissolve into another. Some things dissolve a little, some dissolve a lot. But ammonia, oh man, ammonia is on a completely different planet. And check this out. This quote basically says that you can dissolve around 700 volumes of ammonia gas into just one single volume of water. I mean, think about that. That's not just highly soluble, that is absolutely insane. It's kind of like trying to cram 700 people into a phone booth. It just doesn't seem possible. Okay, so a number like 700 is hard to wrap your head around. But how can we actually see this incredible power in action? Well, it turns out chemists have a really cool and really dramatic way to show us. It's called the fountain experiment, and it is awesome. So here's how it works. You've got a flask, right, filled with ammonia gas. Then you introduce just a single drop of water. That gas dissolves so incredibly fast that it creates a vacuum inside. And because the air pressure outside is now way, way higher, it shoves this colored liquid up a tube and bam, it erupts inside the flask, creating this spectacular fountain. And that's not just for show. That color change tells us something really important. The liquid they use is red litmus, which is an acid-base indicator. And the fact that it turns blue proves that when ammonia dissolves in water, it forms an alkaline solution, or, a weak base. So you get two amazing science lessons in one cool trick. All right, so we know ammonia loves water and it's a weak base. But where does all this stuff actually come from? I mean, how do we make it? Let's dig in. So there are basically two main ways to cook this stuff up. On one side, you've got the lab method. It's small scale, great for demonstrations. You just heat up an ammonium salt with an alkali. But then you have the industrial heavyweight, the Haber process. This thing is massive, and it literally pulls nitrogen right out of the air we breathe to make ammonia on a crazy huge scale. But, if you look closely at that lab setup, you might notice something kind of weird. The flask, it's always tilted. So what's the deal with that? Why the funny angle? It's all about safety. It's actually a really clever trick. See, when you heat the chemicals, you also make some water vapor. If the flask was standing straight up, that vapor could condense at the top, drip back down onto the super hot glass, and crack. The whole thing could shatter. So by tilting it, any water just trickles harmlessly down the side, away from the heat. Simple, but super important. So that lab method is neat, but let's be real. It's not going to feed billions of people. To do that, you need to go big. You need an industrial process that can change the world. And that brings us back to the Haber process. And making this happen is no joke. To force nitrogen, which is super unreactive, to combine with hydrogen, you need the perfect and pretty intense recipe. We're talking seriously high pressure, a temperature that's hot, but not too hot, and you need a catalyst, in this case, finely divided iron, to get the reaction going. Oh, and you throw in a promoter, molybdenum, which is basically a hype man for the catalyst, making it work even better. And when we say high pressure, we mean it. We're talking over 200 atmospheres. To give you an idea of what that feels like, that's more than 200 times the air pressure pushing down on you right now. It's like being more than a mile deep in the ocean. It takes an incredible amount of force to make this stuff. So you might be asking, why go through all that trouble? Why build these gigantic, high-pressure factories? Well, because this isn't just any gas. This is the gas that literally feeds the world. And its uses are just staggering. I mean, we've talked about cleaners and fertilizers, sure, but it's also used as a refrigerant gas. It's crucial for making nitric acid.
It's in explosives like TNT. It's used to make plastics and nylon. It's even in the ammonium chloride used in dry cell batteries. This chemical is an absolute workhorse.
But out of all of that, let's be crystal clear. Its number one most important job is making fertilizer. Over 80% of all the ammonia produced goes into fertilizers. The nitrogen it provides is the key to modern agriculture. Put simply, without the Haber process making all this ammonia, there is no way we could produce enough food for the billions of people on this planet. So there you have it. We went from a familiar, pungent smell all the way to a pillar of modern civilization. It really makes you think, doesn't it? Could ammonia be the single most important chemical that you'd never really thought about before? It's definitely something to ponder the next time you catch a whiff of that very familiar smell.